Today we are going to discuss about exception handling. Exception handling. Okay. What is an exception? When an exception is raised, why an exception is raised, what we need to do when exception is raised. All those things we will discuss. First of all, what is the exception? Okay. Exception is an abnormal situation in the application. Exception is a abnormal situation in the application which is non-syntactical, That means if an abnormal situation arises in the application which is not related to syntax. If the syntax is fine and still there is some abnormal situation in the application, then it is a exception. See, if the syntax fails, if the syntax is incorrect, then it is not an exception, it is a compile time error. Okay? If the syntax fails, it is a compile time error. But if the syntax is correct and still there is abnormal situation in application, then it is called as an exceptional situation. If the syntax is correct and still if there is abnormal situation in the application, then that is called as an exceptional situation. And some of the abnormal situations are recognized by the compiler and some of the others are not recognized by the compiler. Some exceptions or some abnormal situations are recognized by the compiler, but some abnormal situations are not recognized by the compiler. The abnormal situations recognized by the compiler are called as checked exceptions. And the abnormal situations that are not recognized by the compiler but which are recognized by the runtime environment are called as unchecked exceptions. The abnormal situation that is recognized by the compiler are called as checked exceptions, and the abnormal situations that are not recognized by the compiler but recognized by the runtime environment are called as unchecked exceptions. Okay, we have checked and unchecked exceptions. Okay, we will see in depth about checked and exceptions later on. Let me define a new class. From now onwards, If you are writing any class or interface or any, if you are writing any entity, okay, then what you need to do is you need to write it in a package. The standard way of approach, the standard way of defining a class is define a package and define the class under the package. So from now onwards, we will be defining classes only in the packages. Okay. So let me go for a new class, new package. Now let me save this exception demo.java. Let me go for it. Form HCU. Now I have exception demo.java. Now, what is the exception that you already know? Do we have any exception that you already know? We have already defined a class cast exception while discussing about typecasting. Okay. Now, is that class cast exception recognized by the compiler?
No.
Is a class cast exception recognized by the compiler? Yes or no? Is the class cast exception recognized by the compiler? Yes or no? Yes? Yes? Now, is it a situation of class cast exception? Is it a situation of class cast exception? Yes or no? Yes or no? Definitely yes. Just because the reference A1 is pointing to class, the object of class A, and we are trying to typecast into subclass B. If the typecasting list contains at least one subclass or a related class, then it is a class cast exception. Now, will it give a compile time error? Will it give a compile time error? Yes or no? No. If it is not a compile time error, how can we tell that it is recognized by the compiler? The class cast exception will never be recognized by the compiler. Is it syntactically correct?
Yes.
Syntactically it is correct. It will be compiled successful, but at the runtime environment will look for the object that we have created. The object that we have created is for the class A, so the class A object cannot be typecast into B, which is a class cast exception, which is an abnormal situation. Okay, typecasting a higher object into a lower one is a very abnormal situation. Okay, so we have an object. Let's consider like this is A class object and this is B class. Now, can we put this into this? A is higher but B is lower. Can we put this into this? No. So, this is some kind of abnormal situation. Okay? So, this abnormal situation in Java it is represented as A exception. Okay? In Java, each and every abnormal situation is represented as a exception. So, let me try to, I did not go for classes, SRC. Let me go for SRC. So now I have exception Java where I have a class cast exception. Now let me try to compile this. Is it compiled successful? Yes, there is no compile time error. Let me go for classes. At the runtime, sorry. What is this link? It's a java.lang.class cast exception. It's a class cast exception. Okay? So it's telling that it's a class cast exception, and it's a class cast exception because of class A at the line 7. Now it tells like java.lang.class cast exception. Okay? Now one more thing that I forgot to discuss yesterday, okay, is like we have a class string, okay. Now the class string and we have class system dot out dot okay. We are using the class string and the class system. Okay. Now the class string and the class system are there in from where the string and system are available? From gre lib rc.jar. In rc.jar we have a package named java.lang. In the java.lang package, okay, the system and string are available. So the package structure for string is java.lang and the string class is public. Even the package structure for system class is java.lang and the system class is also public. Now what is the current package? What is the current package? com HCU exception demo. Okay. What is the package in which string is there? The package in which string is there is java.lang package. Are they the same package or different package? Same package or different package? Different package. If we are using string which is from different package, do we need to import string class? Logically, if we are using a public class from some other package, do we need to import that class? Yes. But for java.lang package members, the java.lang package members from the library, they will be available default at the time of compilation as well as at the time of execution. The java.lang package members will be treated special. They will be automatically imported. They will be automatically imported. The java.lang package members will be automatically imported. We need not to explicitly import them. They will be automatically available to all the Java applications. The java.lang package members will be automatically available to all the Java applications. So, string and system can be accessed even without importing, just because they will be available to all the Java applications. We need not to import java.lang package members. They will be automatically available to all the applications. That's what I forgot to discuss yesterday. So, now, what is this telling? Just see here. What is telling? It's an exception in thread main java.lang.class cast exception. Okay, this class cannot be typecasted. The class A cannot be typecasted. At which line? At the 7th line. Why it is giving at the 7th line means? Previously it was at the 7th line. Now, at the 7th line what we are doing? We are typecasting A into B, the object of A into B. So it is a class cast exception. So how it is showing a class cast exception? It's like java.lang.class cast exception. If you see in the library, the java.lang, we have class cast exception dot class. Now, even the class cast exception is also a entity. The class cast exception is a class. Not even class cast exception. Any exception in Java, okay, is a class. Any exception in Java is a class, and all the exception related classes are concrete classes. Any exception in Java is represented by a class. Any exception in Java is represented by a class, and all the exception related classes are concrete classes. Not even a single exception class is abstract. All the exception related classes are concrete classes. Now, how the process of exception, how the exception is being raised by the runtime environment. First, we need to learn how the exception is being raised by the runtime environment. Then, we need to learn how to catch or how to handle the exception. First, when abnormal situation is arised or when abnormal situation is observed by the runtime environment, how the runtime environment tells that it is an exception. Means, okay, where the corresponding abnormal situation is raised by the runtime environment, or when an abnormal situation is observed by the runtime environment, first the runtime environment fetches the class for the exception. For each and every abnormal situation, there is a specific class, okay, in the library which represents that abnormal situation. For each and every exceptional situation or abnormal situation, for each and every exceptional situation, there is a corresponding class in the library. For each and every exceptional situation, there is a corresponding class in the library. For invalid typecasting, there is a class which is a class cast exception. So, like that, for each and every abnormal situation or for each and every exceptional situation, there is a class in the library. First of all, when that exceptional situation is recognized by the runtime environment, the runtime environment will fetch that class and will create an object to that class. So, the first thing that is done by the runtime environment is when it recognizes a abnormal situation. When it recognizes a abnormal situation or exceptional situation, then first it will fetch the class corresponds to the abnormal situation and it will create an object to that class. So, first the exceptional class object will be created. The exception class object will be created. The exception class object will be created and if that exception object is not handled, if that exception object is not handled, then the runtime environment will block the process of execution. See, the runtime environment, what it will do means, if it recognizes the exceptional situation, then it will fetch the corresponding exception class and it will create an object to the corresponding exception class. And when the runtime environment says that the corresponding exception object is not handled, then it will block the process of execution. So now let's consider that we have system.out.println before and after. Sorry. Before and after. So now let me see. Let's compile. Let me go to the classes. Let me explain. I think it was not compiled. Sorry. thinking otherwise. So, he is before executed. He is before the system.println before executed. Yes or no? If you see here, okay, system.println before is executed. Okay, and then at the next statement, at the 8th line, okay, at the 8th line it is giving a class test exception. If at the 8th line, if there is a class test exception, is the 9th line executed? No. Just because at the 8th line itself, the exception object, the class test exception object is there, and it was not handled. So the runtime environment will block the process of execution. So the execution will not come to the 9th statement. The execution will not come to the 9th statement. So the execution will be hanged. The system will not be processed. But now we have two kinds of exceptions. We have discussed that we have two types of exceptions. What are the two types of exceptions? Checked and unchecked. Now, class test exception, is it a checked or unchecked exception? Unchecked exception. Just because it's not recognized by the compiler, but it is recognized by the runtime environment. The exceptions that are recognized by the runtime environment are called as unchecked exceptions. Okay? The exceptions that are recognized by the runtime environment. The exceptions that are recognized by the runtime environment are called as unchecked exceptions. Class test exception is an unchecked exception. It is not recognized by the compiler. It's recognized by the runtime environment. Understood? Now, if the exception is there, okay, the exception situations may arise or may not arise in the applications. But at the time of development, we may or may not recognize that exception situation arises. At the time of development, we may or may not recognize that the exception situation arises. But even there is an exception situation, okay, the application should not be hanged. The application should not be freezed because there is an exception. Just because, let's consider like we are making a bank transaction, and in order to make a bank transaction, we have a software application. But because of some reason, because of any reason, okay, let's consider like there is an exception in the application. It might be a bug in the application, or it might be a unavailability of data, or whatever it might be. For whatever reason it might be, there is an exception in the application. Let's consider like when I try to make a transaction, there is an exception in the application, and if the application got hanged, then throughout the users, all the users cannot access the application. Okay. Now, is it a correct thing to hang the application if there is an exception? No, it's not at all a correct thing to hang the application, to block the application, or to freeze the application when there is an exception scenario. When there is an exception scenario, we should, as a developer, we should handle that exception. Okay, and we should make that application to recover from the exception. Even though there is an exception, we should not hang the application, we should not block the application. We should make the application to recover from the exception. If you want to make the application to recover from the exception, we should handle the exception. Okay? Now, how we can handle the exception? How we can handle the exception? Okay? So, in order to handle exception, okay, we have some executable blocks in Java to handle the exception. Those executable blocks are try and catch. Try and catch. These two are executable blocks. So, using try and catch blocks, we can handle the exceptions. Let us see how we can use try and catch block to handle the exceptions. Okay? If we suspect that some statement may raise the exception, what we do is we keep that statement in the try block. Okay? If we suspect that some statement or a block of statements may raise an exception, then what we do is we keep that statements in the try block. The suspected statements will be kept in the try block. The suspected statements will be kept in the try block. And in the catch block, what we do is we'll put the corresponding exception class. What's the exception class? Class cast exception. We suspect that there is a chance of arising a class cast exception. There is a chance of getting a class cast exception at this line. So what we have done is we have surrounded this statement by the try block. We have surrounded this statement which we suspect to raise the exception in the try block, and soon after the try block, we write a catch block which has a class cast exception identifier. It's not a method. This is not a method. The syntax appears to be like a method, but it's not a method. Okay? It's a catch block. The catch block will take a class as an argument. The exception class as an argument. The catch block will take the exception class as an argument. Okay? Now, this is the way how we can handle exceptions. The exception suspectable statements, or the statements that we suspect there might be an exception, will be kept in another try block. The try block can contain any number of statements, even hundreds and thousands of statements also. Okay? And the suspected exceptions classes are kept in the catch block. Okay? The statements that we suspect that may raise an exception. The statements that we suspect that may raise an exception will be kept in the try block, and the suspected exception classes will be kept in the catch block. Okay? And this will handle the exception. So the exception, once how it will be means, first the control will come here, okay, and the control will come here, and there is abnormal situation, so the runtime environment will create, okay, the runtime environment will create a exception object, okay. Creation of exception object by the runtime environment is called as raising exception. Creation of the exception object by the runtime environment is called as raising the exception. That means the exception is raised. The exception is raised when a abnormal situation is recognized by the runtime environment. When an abnormal situation is recognized by the runtime environment, then the exception is raised. The exception is raised means nothing but the object to exception class is created. The exception is raised is nothing but the object to corresponding exception class is created. Now, in this statement we have a class cache exception. In this statement there is a class cache exception. There is a class cache exception object in this statement. Now the runtime environment will verify is that statement in the try block. When an exception object is there, then the runtime environment will verify is that statement is it there in the try block. Is that statement in the try block? Yes or no? Yes. So now the runtime environment will check, okay, in the cache block. In the cache block, is it having the corresponding exception class? What is the exception object he created here? Class cache exception. Now the runtime environment will verify the cache block, whether the cache block has the corresponding exception class or not. Is the cache block has the corresponding exception class? Is the cache block has the corresponding exception class? Yes. The object which is created is class cache exception, and the cache block has a class cache exception. So then the runtime environment will come to a conclusion that this cache block can handle the exception which is raised. So the exception is raised in the 9th statement, and in the 9th statement we have surrounded it in the try block, and when the runtime environment sees, okay, a exception object in a try block, the runtime environment sees a exception object in a try block, what it will do means it will look for the cache block. It will look for the cache block and it will verify whether the cache block can handle the exception or not. Now what is the exception object that is created? Class cache exception. Now what is the cache? The cache contains a class cache exception. So the cache with the class cache exception can handle a class cache exception object. So the exception will be handled and the control will come to the cache block. Now even a cache block is also a executable block. We can write a number of statements in the cache block like this. We can write any number of statements in the cache block. What? Try block as well as cache blocks are executable blocks. Both try and cache are executable blocks. We can write any number of statements. Okay, now it was compiled. Let me go to the classes and let me execute the application. Sorry. So before it is executed and comes to the try block, in the try block there is exception situation. If there is exception situation, exception object is created, and if the exception object is created, then the runtime environment will look whether it is surrounded by the try block. If it is surrounded by the try block, it will look for the catch block. In the catch block, is there any exception class which corresponds to the exception object? Now, the exception object which is created is class catch exception, and even the catch has class catch exception. So, this catch can handle that exception object. So, the control comes to the catch block. If the control comes to the catch block and if the exception got handled, then the flow of application will be normal. Okay, the flow of application will be normal. If the control comes to the catch block and the exception got handled, then the flow of application will be normal. So even after it is executed, here. If you see here, even after it is executed, just because the flow of application became normal. The flow of application became normal. So now can we tell that an exception has been raised here? Can we tell that an exception has been raised here? Yes, exception has been raised, but it was handled. The exception has been raised, but it was handled. Okay? Let's consider that. Now, is there any exception in the try block? Will it give any exception? Will it give an exception? No. So, if there is no exception, it's not an exception just because we are creating the object for class B and we are typecasting into class B. So, B can be typecast into B, it's not a class catch exception. So, it was compiled successful. Go to the classes and if you execute this, if you execute this, before it is executed, and after it is executed. Is it coming to the catch block? No. The control will come to the catch block only when exception is raised and this catch block could able to handle that exception. Okay? The control comes to the catch block only when an exception is raised and the catch block could able to handle that exception. So, if there is no exception, obviously, after the 9th statement, directly it will come to the 15th statement. There is no exception from the 9th statement, directly it will come to the 15th statement. So, the flow of application will be normal until there is an exception. If there is an exception, again the flow will be changed. So, if there is no exception, directly from the 9th statement it will come to the 15th statement. Let's consider like there is an exception. There is a class catch exception. Now what it will do? Here exception is raised and because of the catch block the exception is handled, so it will come to the 13th statement and then it will come to the 15th statement. If there is an exception, it will come to the catch block and it will come to the next statement. Let's consider like we have a catch with another exception class which is null pointer exception. Even null pointer exception is also a exception class. Now, what is the output? Before catch block, after, or before and after? Will it compile successful? Yes or no? Definitely will compile successful, just because the exception that is there is a runtime exception. For compilation it doesn't matter. So at the runtime, what it is doing? Sorry. At the runtime, what it is giving? It's executing before, but the application is hanged at the nth statement. Why the application got hanged at the nth statement? There is an exception object. What is the exception object? Which class exception is raised? What is the exception that is raised here? Class catch exception. But what is the catch that we have? Null pointer exception. But the exception object that is raised is class catch exception, but the catch contains null pointer exception. But the catch with null pointer exception cannot handle a catch with null pointer exception cannot handle a class catch exception. So if the exception is not handled, then what happens? The application, the process of execution will be blocked. See, here in the ninth statement there is an exception. In the ninth statement there is an exception. Okay? And if there is an exception, then the runtime environment will check whether it is surrounded by the try block or not. Now, is this statement surrounded by the try block? Is this statement surrounded by the try block? Yes. So then the runtime environment will check the catch block. Okay. What is the exception class in the catch block? What is the exception class in the catch block? Null pointer exception. What is the exception that is raised? Class exception. But the null pointer exception, a catch with null pointer exception cannot handle class catch exception. A catch with null pointer exception can handle null pointer exception. A catch with class catch exception can handle class catch exception. But a catch with null pointer exception cannot handle class catch exception. So the exception was not handled. The exception is raised, but it was not handled. So the application will be freezed or blocked at the line 9. So it's giving the same at the line before it's executed, but at the line 9 it's blocking the process of execution. So if the exception is raised but it was not handled, then definitely the application will be blocked, irrespective whether the catch is there or not. It's not just a catch will not handle the exception. A catch with a corresponding exception class, a catch with a matching exception class will handle the exception. But not every catch will handle the exception. A catch with a corresponding exception class will handle the exception. A catch with a catch with a corresponding exception class will handle the exception. Some people will think that if there is a catch, the exception will be handled. But if there is a catch with a matching exception class, then the exception will be handled. If there is a catch with a matching exception class, then only the exception will be handled. Shall now what is the output? What is the output? Before? It will execute before. Now, is there any exception here? Class cache exception. So, it will search for a cache with class cache exception. Is there any cache with class cache exception? Yes. So, the exception will be handled and the cache doesn't have any statements. So, directly we come to so, before and after. Now, by seeing this output, can we come to know that there was an exception but it was handled? How we can come to know there was an exception but it was handled? Even there is no exception. Let's consider like there is no exception. Even there is no exception. Here there is no exception just because it's a correct type casting. Even there is no exception and even there is an exception and it got handled. It's the same output. Right? See, even if there is no exception, see in the first scenario we had an exception there. We had an exception but it got handled. Okay? Now let's consider again. Now let me have an exception. Now, will you give a class cache exception? Yes. Yes or no? Yes. So, let me try to compile this. Sorry. Let me try to compile this. Go to classes and execute this. So, if there is an exception, even there is an exception, the output is before and after. Now, what I'll do is, sorry. Now there is no exception. If there is no exception, the output is before and after. Okay? Now let me make an exception. Now there is a class cache exception now. So go to SRC, compile this, go to the classes, execute this. Now even if there is an exception or not, see in the first scenario there was no exception. So it was printing before and after. In second scenario, there is an exception. Again, it is printing before and after. But by seeing this execution, can we come to know that there is an exception, but it was got handled? No. Okay. But we should not block the process of execution. At the same time, okay, we should not leave the exception without notice. So we should have a notice of the exception. Okay. We should notice the exception. We should print the exception in the console or wherever it might be in the logs. Okay, the exception should be noticed, but that exception should not block the application. But if we do like this, okay, if we do like this, the exception was raised but handled, but it was not noticed. But by seeing this, can I come to know whether the exception is raised and handled? No, I will think that there is no exception. As administrator, what I will do? But I will see this log, okay, before and after. So there is no exception. I will think that there is no exception. But how I can come to know that there is an exception, but it was handled? How I can come to know? Means in the cache block, we should print a method. We have a method print stack trace. The print stack trace, what it will do means it will print the description of the exception in the console. Why the exception is raised, at what statement the exception is being raised. If you get exception, then we should print the stack trace of the exception in the cache, so that we can come to know there is an exception and it got handled. so that in the next release we'll modify the code so that the exception will not arise. So the applications will be deployed release by release, first release, second release, third release, fourth release, like that, as per the versions. So in the first versions we can come to know that there is an exception, but it got handled. So in the second version we'll change the code and we'll take care that, okay, this exception will never arise. So that's how it will be. The exception may be raised, but it should be handled. But in the next version what we'll do is, we'll modify the code so that the exception will not arise. Now, print stack trace. What it will do means, the method itself will tell that to print the stack traces. Okay? So, it will print the description of the exception. Okay? Where the exception is raised. Okay? From which line to which line the exception is propagated. All this information will be printed. So, just I'll go to SRC, I'll compile the application, I'll clear the screen and I'll execute the application. Go to the classes, execute the application. SRC. Sorry, there is no exception here. Now let me have exception. Compile the application. Go to the classes. See, before is executed, and because of print stack trace, and because of print stack trace, what happens is this stack trace is printed. Like this is a class cast exception at the line something, and by knowing this, we can come to know that there was an exception raised. There was an exception raised, but the execution was not blocked. So the exception was handled. So in the next release, what we'll do is we will handle the situation. We'll handle the root cause for this exception, so that that exception will not arise. Okay. So, but even the exception was arised, it was handled. So after is printed. So the exception should be raised, the exception should be noticed. So it should be differentiated. Let's consider like there is no exception. Now there will not be an exception. So in this situation what happens? Go to the classes. Let me go to the classes and let me execute the application. So it should be differentiated. If it is a normal flow, just before and after is printed. If it is exception flow, then before is printed and the root cause for the exception is printed, and then the flow will be normal. Okay, likewise we can differentiate whether there is no exception or whether there is an exception and it got handled. Understood? That's how we need to do it. And we can have any number of statements in the try block. We can have any number of statements in the try block. It's not like we have only one statement or two statements. We can have any number of statements in the try block. On a successful execution, all the statements in the try block will be executed. On a successful execution, that means if there is no exceptional scenario, or if there is no exceptional situation, if there is no exceptional situation or there is no exceptional scenario, all the statements in the try block will be executed. Now, if there is no exception, is the catch block executed? No, the catch block will be executed only if there is exception and the catch could be able to handle that exception. If there is no exception, then all the statements in the try block will be executed. If there is no exception, then all the statements in the try block will be executed. Now, what is the output in this case? Before, inside try, before, inside try and after. Just because it will come to this statement, just because it is not an exception situation. So, the output is before, inside try, after. Okay? Now, what is the output? Before, inside try, after. Just because there is no exception situation. So, catch block will not be executed. Compile over the classes and execute the application. So before, inside try and after. Let's consider like there is an exception situation. Now, before catch, what's the output? If there is exception but it was handled. Before catch, after catch, what is the output? Will it execute inside try or will it execute after? Okay. Once the control goes to the catch block, it will never return to the try block. Okay. Once the control goes to the catch block, it will never return to the try block. Once the control goes to the catch block, it will never return to the try block. Once the control goes to the catch block, it will never return back to the try block. So, if that is the scenario, what is the output? Before, catch, after. Just because once the control reaches the catch block, it will not go back to the try block. So, before catch, it will print the stack trace and after. So, this will not be printed if there is exception in the prior statements. So, let's consider like we have some 100 statements here. Are these statements executed if there is exception? No. These statements are not executed if there is a exception. Okay? These statements will not be executed in case there is a exception. So in general what we do is only exception susceptible statements will be kept in the try. Okay, not all the statements are kept in the try, only exception susceptible statements are kept in the try. Okay? Not all the statements are kept in the try, only exception susceptible statements are kept in the try. Now what is the output? Before, inside try, after try, after. Okay, let me give it as end. Now, before, inside try, after try, end. What is telling? It's telling it is a compile time error. A very important thing is there should not be even a single statement before try and catch. After try, it should be a catch. Okay? There should not be even a single statement before try and catch. It might be system.out.println, or it might be some variable declaration, or any statement. We should not have any statements between try and catch. There should not be even a single statement between try and catch. It might be any type of statements. It might be printing, or it might be variable defining, it might be method call, whatever it might be, we should not have any statements between try and catch. It will be a compile time error. Try should be followed by catch. And first try should be there and then catch should be there. If you keep first catch and then try, then also it will be a compile time error. First try should be there and then catch should be there. Okay? And then let me show you the hierarchy of exception classes. Okay? Basically, the exceptions or the abnormal situations are of two types. The abnormal situations are of two types. One is exception and the second one is error. The abnormal situations are of two types. One is exception, second one is error. Exception is abnormal situation which can be recovered through the application. Exception is an abnormal situation which can be handled or which can be recovered through the application. Which can be handled or recovered through the application. But error is abnormal situation which cannot be handled through the application. Error is abnormal situation which cannot be handled through the application. Let's consider like we have a method main, and if we call main from main, now what I am doing is I am calling for main from main. What it will give? If I call main from main, what it will give? It is an error which is a stack overflow error at the runtime. It's a stack overflow error at the runtime. Just because we are calling the same method from the same method. So it tells that it is a stack overflow error at the runtime. So these errors cannot be recovered through the application. Errors cannot be recovered through the applications. We have several errors like see, if we execute, which is a class which doesn't exist. If we try to execute a Java command with a class which doesn't exist, in this no class definition found error. So this error cannot be rectified, or this error cannot be handled through the application. This is abnormal situation, but this abnormal situation cannot be handled through the application. So these abnormal situations are called as errors. And the abnormal situations that are handled, that can be handled through the application, are called as exceptions. Okay? Now, the errors are of two types: compile time errors and runtime errors. The compile time errors are syntactical errors. Okay? The compile time errors are syntactical errors. All the syntactical errors will come under compile time errors. And some examples for runtime errors are stack overflow error. Some examples for runtime errors are stack overflow error, no class definition found error, like this. No class definition found error, step only. No class definition found error. So like this, we have so many runtime errors. These two are runtime errors. So this cannot be recognized at the runtime. Sorry, this cannot be recognized by the compiler, but this can be recognized at the runtime. Stack overflow error and no class definition found error, these are runtime errors. But these errors cannot be recovered through the application, cannot be handled through the application. But exceptions, yes. The exceptions are of two types: checked and unchecked. Checked and unchecked. Checked exceptions are the exceptions that are recognized by the compiler. Some examples for checked exceptions are we'll discuss in depth regarding the checked exceptions. These are some of the examples for checked exceptions. We'll explain them while discussing about the checked exceptions. These are some of the examples for checked exceptions. And all the checked and unchecked exceptions are subclasses to java.lang.exception. Exception is a class which is a superclass to all the checked as well as unchecked exceptions. Exception is a superclass to all the checked as well as unchecked exceptions. And in unchecked exceptions, we have the class runtime exception, which is a superclass to all the unchecked exceptions. And we have many unchecked exceptions like Null pointer exception. Like this, we have a number of random exceptions. I have listed only few. Okay. See, exceptions are categorized into two. One is checked and unchecked. Okay. Either it is a checked exception or unchecked exception. Any exception class is a subclass to the class java.lang.exception. Any exception class, either it is a checked or unchecked, it is a subclass to java.lang.exception, and all the unchecked exceptions are subclasses to java.lang.runtime exception. All the unchecked exceptions are subclasses to java.lang.runtime exception. So, null pointer is a subclass to runtime exception, class is a subclass to runtime exception, arithmetic exception is a subclass to runtime exception. Just because all these are unchecked exceptions. All the unchecked exceptions are subclasses to runtime exception, and again the runtime exception is a subclass to exception. Runtime exception is a subclass to exception. So the exception is a superclass. The java.lang.exception is a superclass to all the exception classes. To all the exception classes, they might be checked or unchecked. And the superclass to java.lang.exception, we have this is the supermost class in the exception hierarchy. Throwable. Throwable is the supermost class in the exception hierarchy. Throwable is the supermost class in the exception hierarchy. Extending through throwable, we have exception. Let me show you as a diagram so that you can understand it better. First, we have supermost class is throwable. First, abnormal situations can be categorized into exceptions and errors. And in errors, we have compile time errors and runtime errors. And this exception, okay, for this exception, supermost class is throwable. Okay, the supermost class in the exception hierarchy is throwable. Extending throwable, we have exception. This is the class. Exception is a class. Okay, and okay, we have two categories of exceptions. One is checked and unchecked. Throwable is a class as well as exception is also a class. All the classes in exceptions are, okay, all the classes in exceptions are concrete classes. Not even a single class is abstract. All classes are concrete classes. So we have several examples like class performance exception. You want to solve the exception? SQL exception. I1 exception. We have several examples for unchecked exceptions. But all the unchecked exceptions are subclasses to runtime exception. Intern, what are exceptions? Last class exception, and so on. There are many unchecked exceptions. I have explained it. This is the hierarchy of exceptions. The supermost class is throwable. Extending to throwable, we have exception, and exception is the superclass for both unchecked as well as unchecked exceptions. Okay, and some of the checked exceptions are this, and all the unchecked exceptions are subclasses to runtime exception. And we have some of the examples for unchecked exceptions. This is the hierarchy of exceptions, and this is very important for us. So some of the examiners will be asking, what is the hierarchy of exceptions like? Okay. So first throwable, extending to the throwable, we have exception, and all the checked exceptions are subclasses to exception. Now all the unchecked exceptions are subclasses to runtime exception, which is in turn a subclass to exception. Understood? No. A catch with super exception class. A catch with super exception class can handle subclass exceptions. A catch with super exception class can handle subclass exceptions. A catch with super exception class can handle subclass exceptions. A catch with super exception class can handle subclass exceptions. So if it is the case, now what is the output? Before catch, and now can a catch with runtime exception handle class exception? Can a catch with runtime exception handle class exception? Yes or no? Definitely yes. Just because runtime exception is a superclass to class exception. So a catch with super exception class can handle subclass exceptions. A catch with super exception class can handle subclass exceptions. Now let's see when a null pointer exception will be arised. Okay, null pointer exception will be arised when a reference variable is used. Let me explain with the example so that you can understand better. A null pointer exception is arised null pointer exception is arised when a reference variable is used to access attribute or a method. When a reference variable is used to access attribute or a method and the value of reference variable is null. If you are using a reference variable to access attribute or a method, but if the reference variable is null, then it is a null pointer exception. Using null as a reference, in turn we can tell that using null as a reference, if we access an attribute or a method, then it will be a null pointer exception. Using null as a reference, if we access an attribute or a method, then it is a null pointer exception. Now, will it raise a null pointer exception in the 8th line? Will it raise null pointer exception in this line? Yes or no? Yes, just because we are using str as a reference to access length, which is a method inside string class. But we are using a reference variable to access a method, but that reference variable is null. So, the reference variable is null and we are using that reference variable to access a method. So that it is a null pointer exception. If a reference variable is null and if we use that reference variable to access an attribute or a method, then it will be a null pointer exception. Now definitely it will be a null pointer exception. Okay? Just if you try to compile and execute this. It will be compiled. It will be compiled. But at the time of execution, it gives a null pointer exception at the line 8. Tells that there is a null pointer exception at the line 8. What's the line 8? Here. Just because the value is null and the length method is used using a reference variable that has the value as null. But the compiler will never check what is the value of str. For reference variable, the compiler will never check what is the value. The compiler will only check what is the data type. Data type is str, which is of type string. Is there any length method in the string? Yes, that's fine. But at the runtime environment will check where str is pointing to. Where is str pointing to? Null. Using null as a reference, okay? If we try to access an attribute or a method, then it will be a null pointer exception. Understood? Now, will it be a null pointer exception or not? Will it be a null pointer exception or not? Yes? 100%?
Yes.
Will it be a null pointer exception or not? Yes? Yes? Sure? That's why I asked. It will be a compile time error. Okay, that's why I told. While referring to the current concepts, you need to remember the current concepts as well as you need to remember even the previous concepts also. This will be a compile time error just because str is non-static and it is being used directly in static method main. So it will be a compile time error. The runtime null pointer exception will be recognized only at the runtime. But if it wants to come to the runtime, first it should be compiled perfect. It will not be compiled just because it's non-static and it is being used. Now, will it be a null pointer exception? Will it be a null pointer exception? Yes, just because default value of str will be null. So, what we do is, in order to handle this, what do we do? We'll put in a try block, and in the catch block, now what is the output? Just make it here. What's the output? Before catch end. The output is before catch and end. Just because in the 9th statement there is an object of null pointer exception, and the runtime environment will verify whether there is a catch which can handle null pointer exception or not. So there is a catch which can handle null pointer exception. Okay, so it will come to the catch and it will come to end. So now null pointer exception is also a class in java.lang package. So even without importing, we are using null pointer exception just because it is a class in java.lang package. Null pointer exception is a class in java.lang package. So we are not importing that. We are using even without importing. The string, system, null pointer exception, all these are classes in java.lang package. So we are not importing them, but even without importing, we can use them. Understood? Now the output is before catch end. Before catch and end. Now no? Now what happens? Will it be a class class exception? Will it be a class class exception? Yes or no? Yes. Definitely it is a class class exception just because it's the object of A and we are trying to typecast the object of A into B. So it will be a class class exception. See here it's an object of A class and the object of A class is being typecasted into B class, which will be definitely a class class exception. But do we have a cache for class class exception? No. Now, will it be handled? Is the class class exception which is raised in the NaN statement, is it handled? No. Now, what is the output? It will execute before and at the NaN statement it will hang the process. So, it will be compiled, but while execution, okay, it will execute before, but it is hanged at the 9th statement. Okay, so how we can handle the class cast exception here? How we can handle the class cast exception means we can have multiple catch blocks. We can have multiple catch blocks for the same try. For the same try block, we can have multiple catch blocks. For the same try block, we can have multiple catch blocks. This is possible. And between try and catch, as well as between multiple catches, there should not be any statements. Between try block and catch block, we should not have any statement. As well as between multiple catches also, we should not have any statements. There can be any number of catch blocks for the same try block. There is no limit. There can be any number of catch blocks for the same try. We can, but we won't. Now, what's the output now? Before catch CCE, catch NPE, end. Just see once again. Before catch CCE, catch NPE, end. Or anything else. Before catch CCE, end. Okay. It will not come back. It will not come to the catch null pointer exception. Just because once there is an exception in the 9th statement, from the 9th statement, it will. There is an exception class. What is the exception object in the 9th statement? Class cast exception. So it will check. Okay, whether there is any catch which can handle class cast exception or not. And the exception handling mechanism is a trial and error mechanism. So first there is a class cast exception, and the runtime environment will check whether the first catch could be able to handle it. Whether the first catch could be able to handle class cast exception? No. So it will try the first catch. It's not possible, then comes to the second catch. What is the second catch? Class cast exception. Now, is the class cast exception catch handles that exception in the 9th statement? Yes. So it will come to this catch block and will execute this statement. And once the control comes to the catch block, it will never return to the try. Once the control comes to the catch, it will never return to the try. So first it will execute this statement. There is a class cast exception, so it comes to the corresponding catch. Okay, and it will execute catch CCE, and again it will come to the next statement after the catch. Once the control comes to any of the catch blocks, once the control comes to any of the catch blocks, then the control will never return back to the try. Once the control comes to any of the catch blocks, then the control will never return to the try. Now, Before catch NP n. Before catch NP n. Just because it come before. Now, is it raising a class exception? No. So it will come to the next statement. In the next statement, str is null, and we are accessing a method using str. So it is a null pointer exception. Now, do we have any catch with null pointer exception? Yes. So it will come here and will execute catch NPE and it will come to end. So only the corresponding catch will be executed, and once the control comes to the catch, it will never return back to try. Now let me consider that it's catch 1, it's catch 2. So now what is the output? Before catch 1, why it should not go for catch 2? Even runtime exception can handle null pointer exception. It's not superclass or subclass. As I told just 2 minutes back, exception handling is a trial and error mechanism. First, if there is an exception, now in the 10th statement there is an exception. What's the exception? Null pointer exception. So first the runtime environment will verify whether the first catch could be able to handle that exception or not. Whether the first catch could be able to handle the exception? Yes. So it will not come to the second catch. It's not because of exact match. It's just because exception handling is a trial and error mechanism. First it will try for the first catch. If the first catch is not valid, then it will go for second. If second is not valid, then go for third. Third is not valid, then only it will go for fourth. Like that, the exception handling is a trial and error mechanism. So, if I execute this, first if you give before catch 1 and end. Okay? Now what is the output? Before catch to end. Just because it will come to before, and here there is a class exception. Since there is a class exception, it will try to handle the exception. The runtime environment will try to handle the exception using the first catch. But is the first catch able to handle the exception? No. So it will come to the second catch. Is the second catch could able to handle the exception? Yes. So it will come to the catch 2. Okay? Like that it will be. Okay? The exception handling will be a trial and error mechanism. Before catch 2 and end. Now, before catch 1, before catch 1 end, or before catch 2 and end? Before catch 1 or catch 2? 1. Okay, but this will be a compile time error. This will be a compile time error. We can have multiple catches We can have multiple catches for the same try block, but those catch blocks should be in the ascending order of the inheritance. We can have multiple catches for the same try, but the catch blocks should be in the ascending order of the inheritance. We can have multiple catch blocks for the same try, but the catch blocks should be in the ascending order of the inheritance. Okay? So it's giving compile time error. So why it gives a compile time error means, let's consider like just think at the time of execution. Okay? Now, is there any possibility to come to this block? Is there even a single possibility where the control comes to this block? When a null pointer exception is raised, definitely it will go to the first statement, and there is not even a single possibility where this statement is executed. So this block will come under unreachable block, and unreachable statements or unreachable blocks are compile time errors. So as a rule, okay, multiple catch blocks can be there, but multiple catch blocks should be in the ascending order of the inheritance. So this is the correct order. And now, can this catch handle both the exceptions? Null pointer exception, classless exception? Can this catch handle both the exceptions, null pointer as well as classless exception? Yes. Now, which one is better? Writing a single catch which handles all the exceptions, or an approach like this? Let me comment this. Let me put let's consider like there are two more exceptions, we need to go for two more catches. Which approach is better? Writing individual classes for individual exceptions, or writing a single catch for all the exceptions? See, if we write a catch with a runtime exception, we can handle all the unchecked exceptions. Writing a single catch block with super exception class is advisable, or writing an individual catch for individual exception is advisable. Which one do you think it is better? See, if you write a catch with a runtime exception, we can handle all the unchecked exceptions. Then why you should go for individual? If there are 10 runtime exceptions, then you should write 10 catches. Rather than writing 10 catches, we can handle all the exceptions within the same catch. Then why do you think that individual exceptions is advisable? See, using the print structures, we can come to know what is the exception which is raised. To know what is the exception which is raised, we need not to go for separate exception class. To know the exception which is being raised, we need not to go for separate catch. Just because using the print structures, we can come to know what is the exception which is raised. Understood? Using the print structures, we can come to know what is the exception which is being raised. Let's consider like I have catch with the runtime exception, and if I put print stack trace, see, this print stack trace will be this print stack trace or exceptions or whatever it might be. See, for the customer, what he needs, the process of execution should not be blocked. The customer need not know what is the exception, whether it is a null pointer exception or arithmetic exception or class case exception. Is it required for the customer to know it is a runtime class case exception? It's not required for the customer. For the customer, it's not required to know whether it is a class case exception or runtime exception. It's not up to him. Let's consider like my father is there, he's going for a bank, okay, and he is drawing money. If I show class case exception to my father, can he understand that? No, it's not up to the customer to know what is the exception. It's up to the developer to know what is the exception. Right? See, I'll show you. Just wait for a minute, I'll show you. Okay, I have a catch with runtime exception. Right? Even there is a super exception class, if I execute print stack trace, okay, I can come to know what is the exception. It's a null pointer exception. So, in order to know what is the exception, I need to write separate exception classes, separate catch blocks with separate exception classes. Even without writing separate exception catches, even with a single exception catch, okay, with a super exception catch, we can come to know what is the exception which is raised. To know what is the exception which is raised, we need not to have individual catch blocks. Definitely, individual catch blocks is advisable, but not for the reason to know what is the exception raised. For the reason to write different logic for different exceptions. So in a catch blocks, what we write? We write the logic, okay, when the exception is handled. When the class case exception is handled, we can write some logic. When the null pointer exception is handled, we can write some other logic. When the arithmetic exception is handled, we can write some other logic. To write the logic specific to exception when it is handled, we prefer individual catch blocks. Okay? To write the logic specific to an exception when it is handled, we prefer individual catches with individual exception classes. To write separate logic or to write specific logic for a specific catch. To write a specific logic for a specific exception class. To write a specific logic for a specific exception class. When that exception is handled. When that exception is handled by the catch block. We go for a specific catch block with a specific exception class. Rather than writing a generic exception class in a single catch, rather than writing a super exception class in a single catch, we go for specific catches with specific exception classes. So that we can write the logic or we can execute the logic specific to the exception. Let's consider like when null pointer exception is raised, I want to execute some 10 lines of code. Then I can write the 10 lines of code in the cache with null pointer exception. But that code need not to be executed for class test exception. So to achieve that kind of decoupling, okay, we go for individual classes with specific exception classes. Okay, we go for individual catches with a specific exception classes. We go for individual catch blocks with specific exception classes. Okay, we prefer that. It's possible, like we can have a single catch with super exception class. Even that is possible, but that is not at all advisable. It can be appear simple,
It appears simple, but at the time of maintenance, okay, it's not simple to see whether it is simple or not, whether it is useful or not, or whether it is simple or not. We need to check with the application maintainability and performance, not whether it is easy to develop or not. Most of the developers, what they will think is, if it is easy for them to develop, they will follow the approach. But it's not the way to analyze the things. Okay, it's not the way of doing the things. How we need to do is, we need to make it easy to maintain. We need to make it easy to perform. We need to make it better to perform. Okay, so what we need to do is, we need to think in the context of the performance and maintainability of the application, not the time to develop the application. Time to develop the application may be increased, but it is acceptable when the performance and maintainability is better. So we should not think about the time to develop the application, but think about the performance and maintainability of the application. The maintainability as well as the performance is better if we have individual cache logs. So in general, we prefer individual cache logs. Unless there is no logic when the exception is handled. If there is no logic when the exception is handled, obviously we'll go for a single cache log. In that case. But in general, when exception is handled, we'll have a logic to perform. In most of the cases. In many or most of the cases, when exception is handled, we definitely have some logic to perform. So, in general, we prefer to individual cache logs. Okay? Understood? And in the tomorrow class, we'll discuss some more things about the exceptions.